Hi, my name is Seth, and this is an update video that I'm making to a video I made a few years ago with the ESP32. I had done something with a little OLED screen, and I had pushed some images to that. Recently, a YouTuber tried to use the library, and they said, hey, they couldn't get it to work correctly, and so they had looked for a little bit of help on that. And so this is just a follow-up video to that. I told them I'd go ahead and try to look at the code, which it's awful code. I wrote it 4 years ago. I wrote it hastily in the middle of the night. I didn't try to clean it up or do anything special with it. Honestly, looking at the code, there's a few pieces of argument, or there's a few arguments that I pass in that I'm not sure do exactly what I think they do, or thought they did back then. But that's okay. It still works relatively easily. I'm not going to spend a lot of time on it, so I just spent a few hours there to clean up the repository and push some updates to it. So we're just going to walk through it step by step, getting it working on that exact same ESP32 board that I originally had. Uh, and we'll kind of just make sure that everything works, and hopefully that'll be useful to Don. All right, so we're going to go ahead and start out by cloning the GitHub repository. So git clone, and I've already copied my um, repo there. And then I am going to um, I'm going to create a directory in here called bin that I'm going to actually put a new MicroPython binary install that we're going to push to that ESP32, so we'll just call it bin. And I've already downloaded that, the recent one for the ESP32, so I'm just going to go ahead and paste that in there. So we have it when we need it. We can go ahead and close this now that we've cloned the repo, and I'm going to go ahead and open up this folder here in VS Code. Um, yeah, we'll deal with this in just a second. And then the first thing that I'm going to do is open up the README, and I'm just going to go ahead and follow this. Now, if you're on Linux, or if you're on Linux or Mac, you're going to have to change some commands from like Python 3 to Python. You'll also probably have to change some of the stuff where it talks about your COM port to whatever COM port you currently have. Um, but most of the script should work pretty similar on Mac and Linux. I am doing this on Windows though, so your mileage may vary there. We're just going to go ahead and walk through this README file here and just confirm that it's working. So we've cloned the repo. I'm going to go ahead and create a new virtual environment. So python-m env, oops. And then I'm going to go ahead and install these two instructions here, say install ESP2 and install AMPI. I'm going to go ahead and install both of those here as soon as um, this is up and working. We'll just go ahead and copy this, paste. I'm going to put a comma here and actually do AMPI. We'll do both of them at the same time, even though they're on separate instructions here. Release repo available. Invalid requirement ESP tool. Oh, right. Sorry. I forgot to activate my environment after I switched to it. So we made the environment, and we just need to do env slash script slash activate. There we go. And then um, here in VS Code, does not look like it's automatically picking up my environment like it normally does. I'm just actually going to close VS Code and reopen it. See if it automatically picks up that virtual environment for me. So pi. Yeah, okay. So it did pick up the right environment for me. We're good. That's probably just because it's actually on the README file, which wouldn't have anything. Okay, so ESP tools. I should just say install ESP tool instead of ESP tools, but that's okay. And we got AMPI. Now we're going to go ahead and erase the chip. I do need to find out what COM ports it's on. I'm going to use the mode command here on Windows. There's a couple other tools you can use. You can go look at Device Manager. COM port 1, that's not my device. We're just going to wait here and see if it populates. And there you go, COM port 11, that's the frequency it's on. So we're just going to need to change my script here in a couple places for COM 11 on this. I developed this on my laptop, and then this is my desktop, so the COM ports are slightly different. Apparently, I can't spell the word experimental. That's shameful. We'll have to, or similar. Jeez, you can tell I wrote this in the middle of the night. We'll have to put those commits to there right now. Uh, uh, don't mind me. not save? Maybe it didn't save. Try again here. There we go. This isn't part of the tutorial. This is real programming, folks. This is how it really happens. All right. Repo's updated. Good deal. Pushing to master, just like you should. All right, so we're gonna go ahead and erase the ESP since we know that it's working, or that we can see it on the COM port. We need to change it to COM 11. ESP tool is not recognized in internal and external command. I guess I should just make sure that it's installed. ESP tool.py. Right, virtual environment. Yes. Did I not do? Right. I'm so dumb. I forgot. Ah, jeez. It's early. I have not had any coffee this morning. So we were about to install these, and then I remembered that I had not switched to my virtual environment, which is what started all this. All right, so we're gonna do Adafruit AMPI and ESP tool. Let's try this again. Adafruit AMPI. Did I misspell it? Pip install Adafruit AMPI. Not sure why that wasn't working there. Maybe it won't let me separate those out, actually. We'll just do them separated after all, apparently. I don't know what I'm talking about. And then ESP tool. There we go. All right, so both packages are installed. We'll go ahead and do that erase again. You can see here, it's saying that's failing, and that's because I need to put it into the program mode that first time, and then it should work. So we're just going to restart it. Chip needs to be in download mode. Yes, I know. Try again here. Download. There we go. So I had to press the download button while it was waiting there. You can see here it's erasing flash, and then it might take a while. All right, and while we're waiting, we're just going to turn on an external camera here. Now you can't see anything, but it is actually pointing at the screen of that little ESP32. So as we do this, we should start to see stuff. All right, so next command, ESP-tool. We're going to go ahead and write the MicroPython binary to that device. Oh, I did COM8. Well, that's not going to work, is it? There is no COM8. Forgive me. There you go. Failed out there. All right, COM11. Thinking is hard. And once again, I'm going to press that download button. Oh, never mind. It did it automatically. It triggered. Good. So we're going to wait a second here while it goes ahead and downloads. And through the magic of video cutting, so fast. And it's done. All right. So now it should be pretty straightforward. So if you wanted to, you can start using AMPI now. And we're going to go ahead and use AMPI and just do an ls on this. And you should see the default file system. So with AMPI, we're going to go ahead and use the COM port and then select the baud rate. And then this delay, I have no idea why you need it. I don't really get it. It seems to work differently for different folks. So your mileage may vary. If you don't set it, it takes it takes AMPI like a super long time to run the command on the ESP32. I don't know if it's waiting for like an endline character or waiting for something, but it takes forever. If you just go ahead and set it, well, what is this? Well, that's good. Good job, Windows Defender. We're just going to go ahead and set it to 0.6. 0.5 works as well, but someone online said that 0.6 or 0.75 works for them. You do whatever you want here. I'm going to put 0.6. Missing command. Oh, right. So we're going to go ahead and do that. Then we'll do the ls command. And if we do this, we should get back. There you go. So we can see that there is the boot.py, which is what we'd expect after a precedence installation. All right, so you can push files directly to the board by using the commands here that I have. You would literally have to go through and do this with every file, though. So that's up to you, depending on your project size and what you want to do. but you can just go ahead and I have to change it to 11 again. Put those files over to the ESP32, and as we look at this, I'll go ahead and do another ls on it. We can see here now it's got boot.py and demo.py. So let's talk about boot.py. So my boot.py is just the classic boot.py that would be pushed there. I do have it in my working directory because with my sync tool, which I'll show here in just a second, it's literally going to wipe out everything on the file system there. So I need to go ahead and put it back over there even though it's doing nothing. After boot.py, main.py runs. If you read the MicroPython documentation, they'll tell you that main.py is the file that will run after boot.py. And all my main.py does is import demo. Demo on import goes ahead and runs the demo scripts here. So this is what it should have looked like on the repository, but didn't. You can see here that the first thing we do is we set up a I2C and LCD interface. You are going to have to use your pins. Now for me, the SCL is 4 and the SDA for the I2C C bus is 4 or 5. You're going to have to adjust this to whatever it is on your particular board. So this could have been an area where it wasn't working correctly for you before. And then once you do that, you'll go ahead and get these values back. The reason why you get I2C is in case you wanted to use this in your project later on, because it is the I2C bus, so you could have other stuff attached to it. So you might want to get and do stuff with it later on. But for actually displaying the images, all you need is the LCD object. So single image, we're just going to display. That is this ash.pikachu PBM that is in the images folder. So you can see we specify the directory and then we specify the file name. And then true is for whether we want to invert the image or not. That depends on how you created the PBM file. You'll have to play around with that. Most of the time, for me, it seems like I want it to be true. There's only a couple times that I would want it to be false. If you want to know more about these, you can go ahead and look at the actual display.pbm. And for each of these, you can see there's a pretty long argument list. And then it'll talk about those here in the doc string for them, what they are and what they are supposed to do for display image, display slideshow, and display animation. And it's pretty straightforward. So the demo.py is just going to go through and it's going to show one image, then it's going to go ahead and go do a slideshow, and then we're going to do 3 different animation demos based on the animations that are in these folders here. Each image does have to be pushed over. You can use the converter to convert the videos or the GIF image into the correct format. If we look here at Mario.dance, we can see that there's 23 files. So you can see here, that's that 23 saying how many there are. This is basically your frames per second, right? So this number right here is how many milliseconds it's going to show a frame. If you were going to show something at like 30 frames per second, what you'd see for like a standard video today, that would be about 33 milliseconds per frame, correct? I think so. Yeah, should be. I don't know. The other parts here, like I said, all these other comments, so like the invert or the duration or the looping depends how the particular thing works. So like for the slideshow, you can see here this is for how long it's going to stay on each image, and this is how many times it's going to loop. If you do like a -1, which it'll say in the doc string for this, for the slideshow, you can do a -1, and then it will basically loop forever. So yeah, basically added doc strings, fix some of these that weren't working quite correctly. So you should be able to use these now. Um, the sync.py file, which is what I'm going to use now, is a file that will go ahead and take some connection information. So I'm going to go ahead and change this to 11. And it's going to go ahead and take 2 lists. One of them is a list of directories, and one of them is a list of files. If you want to copy individual files over to the machine, you can go ahead and put them into this list up top. And if you want to copy individual directories over, you can go ahead and put it here. Technically, if you just wanted to dump everything out of this folder onto your ESP32, which you actually would not want to do here, because like there's no way that this executable would ever fit on the Pi, and there's other junk here you wouldn't want to do, like the bin folder and stuff like that. You could uncomment this // for me, I want to make sure that my root files get copied over here that's going to run this, and I want to make sure that my animation folder and my images folder gets copied over. And it's going to copy over anything in those as well. And we're going to go ahead and follow directions here. We're going to go ahead and use that sync.now just to see that in action. Go ahead and sync to device. And I just want to make sure I did do the right COM port, right? Yep, okay. And now this may take a very long time because, like I said, it takes like 3 seconds per file, and for those image folders, there are quite a lot of files, so it could take a little time. Of course, if you don't actually run it correctly, it's gonna take a ton of time. Python sync to device. There you go. You're going to notice saying it's going to wipe everything. It really does wipe everything. It wipes everything off of the file system. So just be warned in case you had anything like log files you had written to it or something like that. It does wipe everything. And we'll just go ahead and hit enter. See, and here'd be a good example of a file I'd want to get rid of. So it looks like I've got this Yoshi walk.gif that was from the original GIF that I made. And that is actually going to get copied over to my the ESP32, which it is very small, so it's not going to matter, but I would normally not want that file to be copied over. So you do have to be careful when you choose a directory because everything in the directory is going to get copied over. So you can see here it's removing all files and directories on the device. This does take a little while for it to do. Like I said, you can adjust this delay. Sometimes adjusting this delay can help a little bit. Well, it took an unusually long time. So we're just going to run the command again here and see if it'll work correctly here. Make sure I got the port right. And I'm going to change this delay to 0.75 since somebody online said to do that. Sync. Try again here. Yes, we want to do it. Although you'll notice I still forgot to take out the Yoshi GIF. Okay, and for some reason on this machine, so my laptop it was less. On this one, I had to change it to delay 1 in order to get it to not hang. So, as I mentioned, it might also vary. And you can see here, sending new sync files. This may take some time if you have a lot of files, which we do. We got like 70 something, 80. So yeah, unfortunately, this takes a while. Your choice. How do you want to do it? As I kind of mentioned, some of those extensions or UPyCraft allow you to do like a bulk file upload to or put to the device. So for some of those, it might be useful to use it. This has actually kind of been an issue that I personally have had with MicroPython is that there's all these tools for it, but none of them seem to like work perfectly or without errors or random bugs and stuff like that. So it makes it a little frustrating to work with. Again, UPyCraft, although it's old and kind of clunky, has been my smoothest workflow for working with the ESP32 in MicroPython. I just wish it was a lot better because not having any sort of it doesn't have any sort of font, any styling, any coloring, any syntax highlighting, anything like that. So, but it does make sending files to your ESP32 extremely easy and downloading them back off of it pretty easy. And it's got some pretty good libraries, sort of kind of libraries ready for it. Although I should mention that that first um, extension that we looked at there that was in Chinese or had a whole bunch of Chinese on it was RT Thread or whatever it was. That one actually has a whole bunch of examples that comes with it as well, so it's pretty good. And we're just going to pause the video here as we finish up the rest of these files. You can see here it gives you a little bit of an estimated time remaining. It does count too, so it looks like we're getting just under, um, or yeah, it's about 3 seconds per transfer. And now for the exciting conclusion of slow file transfer. Alright, as this transfers, the ESP should restart. And hopefully now that we have all these files, we will actually see something useful here. I am going to go ahead and follow the README, and we're going to go ahead and run this ampy command here to look at the file system now. Change the COM port again. And that's great. That's what we want to see. Again, we could do like ANI slash I'll do street F just to see. Whoa, looks like we got some sort of, oh, I misspelled street. Life is hard. And yeah, so it looks like all of our Street Fighter animations went and got copied over. So now what I'm going to go ahead and do is just restart the ESP32. See my giant finger there. Hopefully I can restart it. And there we go. We can see all of the images there. Oops, hard to see there, I guess. And that waving line thing is just because of the camera and the sync ratio and all that kind of jazz, so I wouldn't worry too much about those. I hope this fixes the problem, Don. I hope you're able to use this and this works for you. If you have any trouble with it, I would say go ahead and just create an issue on the GitHub repository, or leave a comment on the YouTube video. We can kind of go from there. All right, everyone. Take care.